Buenos dias. ¿Qué tal? So we've covered about 30% of my Spanish vocabulary there, so I'm going to switch to English from this point. Good afternoon, everyone. My name is Jeff Brown, and I am the Grails practice lead at OCI. And what I'm going to talk about this afternoon is I want to talk about monitoring and metrics within a Grails 3 application, and we'll get into the details there in just a minute. But just briefly, just a couple of words about OCI. I think most of you were probably in the keynote this morning and heard some great things from Bert about the great work that I think we've been doing at OCI with the Grails practice. So we've grown the team very quickly over the last couple of years from just a couple of us. Graham and I were the original two members of the Grails team at OCI, and in the first couple of years we've grown the team to there are 15 or 16 of us now, and the practice is going great. Business is going well. We're advancing the technology just as quickly as we can and investing considerably in keeping Grails moving forward and keeping Grails relevant. Things are going great. At OCI as a whole, so the Grails practice is just one piece of OCI. The larger OCI organization contains about 130 or 140 engineers. Many hold advanced degrees in their field. And we support really the whole life cycle of software development, all the way from project conceptualization through design, development, and deployment and management. So OCI has services and engineers to support the entire life cycle of application development and management. Another big piece of OCI since the very beginning, so OCI has been around since the mid-90s and has been an open source company that entire time, by the way, which is interesting. There weren't a whole lot of open source companies in the late 90s, but we were one of them. So we've been in business for about 24 years, and training has always been an important part of OCI's business. We've trained over 50,000 folks over the years. We've got more than 100 current course listings on the website, 30 or 40-ish instructors, and we don't have any professional instructors. All of our instructors are folks who are experienced, high-level practitioners in whatever field it is they're training. So, for example, I deliver a lot of our Grails training. So we don't have folks whose job it is to be trainers. We have high-level, serious experts in lots of fields who also can train in those fields, which is great. OCI supports really a bunch of open source technologies. Of course, Grails is a big piece of that, and the part of the business that I spend all of my time and energy focused on. This is a small subset of our customer base, just some names that you might recognize. And one thing that's interesting to note here is that we service lots of industries: telecommunications, entertainment, aerospace, financial. We service really lots and lots of industries, and that's one of the reasons that Grails is such a great fit at OCI. Is Grails is really a general purpose framework, right? It's not a framework for building financial apps or a framework for building aerospace apps. It's a general purpose framework, and as I said, that's one of the reasons that Grails has been such a great fit with OCI as an organization. As I said before, we're investing heavily in the technology and growing the team just as quickly as we can, moving the technology forward as quickly as we can. Shortly after, or right around the time when we released Grails 3.0, we made the conscious decision to start shipping more frequent small releases. So we're releasing something like 30-something releases a year. So we're issuing releases of Grails at a pretty fast pace. And that's worked out really, really well. There are a couple of reasons that we wanted to do that, and they've both panned out like we thought they would. And that is having these releases more frequent means that we can get bug fixes and new features and enhancements to users more quickly, right? If one of us implements a feature today, in 2 or 3 weeks, there'll likely be a release that has that new feature in it. So there's a shorter time frame between the time when we implement something valuable and when we get it to you. And another reason it's valuable to have those smaller, more frequent releases is they're smaller, right? So it's easier for you to keep your application up to date. So if you're working on a Grails 3.2.8 application today, and next month we release 3.2.9, it's a fairly small release, right? It's just a couple of weeks of work, and that makes it easier for you to keep your application up to date. If you've got a 3.2.8 app today, updating it to 3.2.9 will be trivial. And because it's trivial, you'll do it, as opposed to letting that debt accumulate over time. So we've got a lot of clients that still have Grails 1 applications. And they're just out there chugging along and doing what they do. But those now, when those folks want to upgrade to Grails 3 to take advantage of all the great new stuff that exists in Grails 3, that can sometimes be a substantial piece of work because that application, that technical debt has accumulated for so long. And the smaller releases makes it easier for the application team, development team, to keep up to date with the latest versions of Grails. So enough about the practice and the business. If you have any questions at all about OCI or anything that we've got going on, please come see us at the table, our booth out here in the hall. Where, as most of you know, we're giving away an Apple TV, so please come by and register for the drawing. We'll participate in the raffle Saturday afternoon. I forget what time it is, but whatever time the raffle is in the theater here, we'll draw a name. You have to be present to win the Apple TV. And the reason that we're giving away an Apple TV is it turns out you can build Apple TV applications with Grails. And another thing we've got going on at the booth is we've got a television set up and an Apple TV, and we've got a couple of Grails applications running there. So if you're interested in learning about any of that stuff or talking about it, come by the table and talk to us, and we'd be happy to talk to you. All right. So let's get right into the tech talk. So as I said, I'm going to talk about monitoring and management of a Grails 3 application. And specifically what I'm going to do is I'm going to demonstrate some capabilities that exist in a plugin that we're working on. It's not complete yet, so we're going to be working with a build snapshot. And the idea here is a couple of things. One, I wanted to introduce some capabilities that the framework offers, that the Groovy language and the Grails framework conspire to offer, to make it really easy to do certain kinds of things. And we'll see how that relates to this when I get into an example, the examples that I want to demonstrate. But that's one piece of what I want to focus on. And also, I want to demonstrate what this plugin looks like and the kinds of things that you're going to be able to do with it, because we haven't completed the thing yet. Right now is a great time to solicit feedback and input from the community about what kinds of things you might like to see in a plugin like this. So the plugin that I'm going to talk about is, so we've called it the Drop Wizard Metrics plugin because it's built on top of the Drop Wizard library. We'll see what a little bit of that looks like. And some of the specific things in the plugin that I'm going to talk about is a Meterable Trait and a couple of annotations called metered and timed. And we'll talk about AST transformations, and then also see how tools like JMeter and the JConsole can be used in conjunction with a Grails 3 application. Let's just jump right into it. So to install the plugin in a Grails 3 application, you simply express a dependency on the plugin in your build.gradle. Those of you who have started doing Grails 3 development know that in Grails 3 we revamped the whole plugin system and the way that plugins are bundled and distributed. And one of the significant changes is that in Grails 3, a plugin is just a jar file. It's not so in Grails 1 and 2, a plugin was a zip file that had a special format in it that only Grails could really make sense of. There were certain descriptors that Grails knew how to load out of the zip file. But in Grails 3, a plugin is distributed just as a jar file. So you write a plugin, build it, publish it to Artifactory or JFrog or whatever artifact repository you use. You publish a plugin jar the same way you would distribute any Java or Groovy jar file. So likewise, the way you express a dependency on a plugin is exactly the same as the way you express a dependency on any other jar file. So in your build.gradle file, you've got the dependencies block, and in this case, we're expressing a compile time dependency on the Drop Wizard Metrics plugin, and we happen to be using 1.0.0.build snapshot. As I said, 1.0 of the plugin hasn't been released yet, but the snapshot is out there. So all the stuff I'm going to demonstrate today, you could do this real time right now if you wanted to. That snapshot really has been published to our repository. All right, so we'll start with meters. Meters are one of the things that the plugin provides some support around. So here on the slide, I've quoted from the Drop Wizard documentation. So a meter measures the rate of events over time. That's really what a meter does from Drop Wizard's perspective. So one of the things that the plugin is providing is a trait called Meterable. So in the code snippet you see in the lower right there, you see I've got a class called SomeClass that implements the Meterable Trait. Traits are a really, really super cool feature of the Groovy language. A trait is it's like a class and it's like an interface. It's like a class in that you can declare methods. The methods can have bodies. You can declare properties. Almost anything you can do in a class, you can do in a trait. So it seems a lot like a class. But how traits are fundamentally different than classes is Groovy, just like Java, has a single inheritance model. So when you write a class, that class has one parent class. If you don't declare your parent class, then your parent class is java.lang.object. If you do declare your parent class, then that's the parent class. But you don't have two parent classes, unlike languages like C++, which support multiple inheritance. Groovy does not. So you can only inherit from one base class. So if you had two separate classes that provided behavior that you wanted in your class, you might be able to get there by using delegation. There's ways you could probably get there, but one thing you cannot do is write a class that inherits from two other classes to get the behavior from those two classes into your class. That's not true of traits. With a trait, you can implement any number of traits. So this code here says class SomeClass implements Meterable. That could say implements Meterable, comma, some other trait, comma, some other trait. You can implement any number of traits. And when you implement a trait, what happens is all of the behavior, the properties and the methods that are defined in that trait are added to this class as if you had inherited them from a parent class. So it kind of gets around the limitations associated with single inheritance. So the plugin has some behavior that you might want to use inside of your class, but rather than provide you with an abstract base class that you have to extend, we chose to implement that behavior in a trait. So you can write a class that implements the trait, and we're not tying up your inheritance hierarchy just so you can get this metering stuff in your application. So one of the things the Meterable Trait provides is a method called markMeter. And you can pass as an argument to the markMeter method a string that describes it's the name of the meter. So your program could have lots and lots of meters, right? So here, the meter that we're marking in this code up front is called SomeMeter, right? Just so you can give it any name that you like. And what you see in the background there, the bigger part of the slide on the left, is what a unit test might look like for testing that meter. And one of the things to note there is that in order for the metering to work, there has to be a metric registry instance in the Spring application context. So that's why we've got the static do with Spring block there in the unit test. So we're adding a bean called metric registry to the Spring application context, and the bean is an instance of the metric registry class. That has to be there in order for the metering stuff to work. Now it's there, and what the test is doing is invoking some action over and over again, and then making an assertion about making sure that the meter was incremented the appropriate number of times. Right? So the assertion there at the end retrieves the SomeMeter from the registry and checks the count to make sure that we really are counting the things that we think we're counting. So in your application, you could call markMeter wherever it is that you want to keep track of how many times a certain block of code is executing. Right? So that's one way to get there. Another is that we've provided an annotation called metered. So if that annotation did not exist, one of the things you could do, if the annotation did not exist and the trait did not exist, and you wanted to take advantage of, you wanted to add metering to this class, the code you see here would work, right? So some action is the name of a method that we want to meter. So inside of that method, I can create a name for the meter using that metric registry API you see there, have the metric registry dependency injected into this class. That's the metric registry property. And inside of the method, inside of the SomeAction method, invoke the meter method on the metric registry and pass the name of the meter as an argument. So now I get a meter back, and then I can mark the meter. So it took a long time to talk about, but there's not a whole lot of code there. It's just three lines of code. But even though it's only 3 lines of code, it's tedious, right, to have to do that. And you're going to do the same thing over and over and over in lots of places, and that wouldn't be great. That's one of the things that Grails does really well is it provides mechanisms to get rid of that kind of code duplication, right? If you're using metering, you might be doing metering in lots of places in your app, so you might have this 3 or 4 lines of code copied and pasted lots of places. So the plugin provides an annotation called metered that you can add to a method, and that results in an AST transformation being invoked, which adds the code that you see in the background to your method, right? So you declaratively express that you want this method to be metered. You don't write any of the API specific stuff. You don't have to interact with the metric registry. You don't do any of the stuff you see in the background. Simply declaratively express that you want this method to be metered. And the way to do that is to annotate the method with that metered and provide a meter name. And then all the tedious stuff is all generated for you at compile time. And be clear, it is happening at compile time. So if you're a Java developer who is used to using the Spring framework and using annotations like @transactional and @cached and things like that, then you're familiar. You might be familiar with Spring's runtime proxy mechanism, right? So Spring provides options for doing this sort of thing by creating runtime proxies, and it's a proxy wrapped around your class, and it's that proxy that would be doing the metering. With Groovy, because we've got this really rich AST transformation mechanism supported by the language, we get to fairly easily add code to classes at compile time, not at runtime, but at compile time, and that's what the plugin is doing here. So when you annotate a method with that metered, that causes the compiler to add all the metering code to your class. You don't see it in your source code, but it's added to the bytecode that the compiler generates, which is good. Any questions or comments about any of that so far? You'll have to speak because I can't see past the first row. Yes, go ahead.
I noticed that you don't inject, you don't declare the metric registry in your annotated class.
That's right.
Does that do it in the background?
It does. So the comment is that he's noticed that in the example where I used the annotation, we didn't have to declare the metric registry property, and that's not a mistake or something that's just omitted on the slide. The AST transformation is adding that for you, right? So not only do you not have to put the metering code inside the method, you don't have to declare the property, the metric registry property. The same AST transformation that adds the code in your method is also adding the property to this class. Anything else? Sure.
And would it make sure that it's dependency injected as well? So say I have a domain class after 328, you said it doesn't do dependency injection there. Would that still work?
Yeah, in fact, not only would it work, it relies on that. It doesn't work if the thing is not subjected to dependency injection. So this will only work if the thing is an instance of a bean in the Spring application context. And what's happening is the AST transformation is adding the metric registry property to the class. And then when you add an instance of this class to the Spring application context and configure it to be auto-wired, the metric registry will be auto-wired into this property that you see declared on the left that you don't have to declare on the right. Does that make sense?
It does, yeah, but that means I cannot use it on a lot of classes where dependency injection is not active.
So there are no classes that can't be subjected to dependency injection. So you could use this in any Groovy class, right? But in order for it to work, you'll have to subject that thing to dependency injection or assign a value to the metric registry property yourself.
Right, makes sense. Thanks.
Yep. Anything else? Again, you'll have to be verbal because I can't see anyone. Okay, very good. So another piece of the Drop Wizard library is a timer, which maybe has some things in common with a meter, but it's different than a meter. So a timer is, again, quoting the Drop Wizard documentation, a timer is basically a histogram of the duration of a type of event and a meter of the rate of its occurrence. So maybe that's kind of hard. The wording there maybe is hard to follow, but a timer keeps track of how long something takes to happen, is at least part of what a timer does. So a meter keeps track of how often something happens. A timer keeps track of how long something takes to do, and you might be interested in one or both of those things. So if we didn't have any special support from the plugin to deal with timers, we might have to write code like this, right? So it looks, at least the first part of it looks just like some of the metering code we saw. So I can create a name for the timer and then ask the metric registry to give me a timer with that name and then invoke the time method on that thing, right? And what I get back is a timer that's running at that point. And it will run until I call stop on that timer, the thing called context here in this point. So when I call timer.time, the clock starts running, and when I call context.stop, the clock stops, right? And you want to make sure that it gets stopped, so you might do that inside of a finally block. So in the try block is the stuff that you want to measure. You want to know how long is this taking, right? So that's what this might look like if we weren't using any explicit support from the plugin. But just like the metered annotation, there is a timed annotation. So you can annotate a method with @timed and provide a timer name, and all that stuff is generated for you, right? The AST transformation adds the metric registry property to this class, and it adds all of the tedious code to the inside the method that you've annotated with @timed. Including the try finally, right? So it's doing the right thing. It makes sure that all of the code that's inside of your method is timed and guaranteeing that the timer gets stopped by putting the call to .stop inside of a finally block. Does it make sense? Any questions? All right, very good. Let's before we look at that next bit of code, let's jump into an IDE here and look at a real project. And see some of this in action. So I've got a Grails 3 application here. It's Grails 3.1 application. This would look exactly the same in Grails 3.2.8. This just happens to be a Grails 3.1 app. So I've got a controller in this project called Artist Controller, and it extends RESTful controller. So I'm inheriting all those index, show, update, delete, create, all the default controller actions that are defined in RESTful controller are inherited into this class, and I want to time or I want to add a meter to the show action. So I've overridden the show action, added @metered to the action, and then I've got no special behavior in my version of the method. So I'm simply calling super.show. So I'm really just adding a meter to keep track of how often the show action is invoked. And because the metering is being added at compile time, I can't really add it to my parent class. I can't cause it to be added to RESTful controller because RESTful controller is already compiled by the time my application code gets compiled. So if we decompiled this controller that we're looking at, we would see inside the show method is all the metering code along with a call to super.show. All right. So you might have noticed while I was talking there that the program is logging some information, and the rate is 0. What that rate is it's keeping track of how often the show action is being invoked. And it's not being invoked at all right now. I've just started the application. So that's why our rate is 0. Right? It's never being invoked. So I'm starting up an instance of JMeter, which is a simple and useful way to put a web application under load. And I'll open this JMeter config thing. So I don't want to get derailed into a long talk about JMeter, but what I've just done is loaded up a JMeter config, and what that config is doing is sending requests to the application that we're looking at. And I pressed start, so it's running right now. So over time, we're going to see that number increase, right? So it's at 1.0 right now, and so JMeter is banging on the application. That number is going to continue to increase until it gets up to whatever, however often the JMeter config is actually configured to send requests to the app. But it's increasing right now. Eventually, it'll level off. Is what's important there. So while that's progressing, let's take a look at the Quartz job in this project that is causing the logging to happen, at least indirectly. And in a minute, we'll see directly where that logging is coming from. So there's a Quartz job in the program this is the source code for the Quartz job, and it's configured with a repeat interval of 3 seconds, right? 3,000 milliseconds. So every 3 seconds, this Quartz job gets run, And what the quartz job is doing each time it runs is it's invoking this log metrics method on the metrics logger service. And metrics logger service is not part of the plugin, it's part of my application here. So every 3 seconds, the metrics logger service gets invoked. And what the metrics logger service is doing is this. So this is the method that the quartz job is running. And what this method is doing is retrieving a meter from the metric registry. It's retrieving the show artist meter and grabbing the 1 minute rate. There's a 1 minute rate and a 5 minute rate. There's different rates associated with that meter. And then there's some conditional logic here that if the current rate is higher than some threshold, which is currently hard-coded to be 10, if the current rate is higher than that, then I want to log a warning. And if it's less than or equal to that, then I'll just log an info message. And if we go look at our logging, you see these are all in. It's just about to cross over the 10 point. So those are info messages right now, and momentarily it will increase to be just above. There we go. So it just now crossed over the threshold. And the idea here is that we want to keep an eye on the application and know how often a certain thing is happening. And if it gets above a certain threshold, we want to react to that. And in my simple example, the reaction is just we're logging a different message, and that's just to represent that we can recognize that we've crossed a threshold. But you get to do whatever you want when you cross that threshold. It may be the case that once you get above a certain threshold, you want to send an SMS message to the operations people so they know, hey, maybe things are under heavy load here, maybe we need to spin up some more instances. Maybe it's more automated than that, and instead of sending an SMS to the ops folks, instead of doing that, maybe you make a REST call to some API that will automatically spin up more instances. So the details of what you might do in response to crossing some threshold, that's up to you. You get to do whatever you want. In this case, I'm simply logging 2 different messages so we can tell whether we're above or below the threshold. Right? Notice that this class is annotated with @managedResource, and there are a couple of methods in this class that are annotated with @managedAttribute. One of the things that changed in Grails 3 is we re-architected really the whole framework to be built on top of Spring Boot. And one of the great things about that is, so that means every Grails 3 application is a Spring Boot application. So that's good because anything you can do in Spring Boot, you can do in Grails 3. There aren't any exceptions to that. Anything you can do in a boot app, you can do in a Grails 3 app because a Grails 3 app is a Spring Boot app. So we can use Spring's managed resource and managed attribute annotations. And what those are doing is causing this service to be configured as an MBean using a JMX. Right, so I'm going to start up a JConsole so we can connect to that MBean and start to interact with the system and do some slightly interesting things here. So I've just started up JConsole. I've connected to the process that our application is running in, and momentarily that'll connect. It's going to ask me if it's okay to connect insecurely, and I will say yes. And then what we'll see is there's an MBean in the that's been registered that is an instance of this metrics logger service, and then we can interact with that thing. Unclear why that's going to take a few minutes. Let me stop that. Maybe I selected the wrong. No, that's the one I want. Insecure connection. Make sure the app is still running. It is. So I'm going to give JConsole a minute and see if that gets connected. But what we're going to see is that this bean will be in the registered as an MBean, and using JConsole, I'll be able to manage both of these attributes. Right? So there's a read only. It's really one attribute with a read only, a reader and a getter and a setter, I should say. So through JMX, what we're going to be able to do is we're going to be able to invoke this effectively, invoke this method remotely, and change our threshold. Let me stop this, and if the JConsole thing ends up not being happy, we can carry on without that, but we'll take one more swing at it here. Let me do that. We'll get JMeter running. while that's starting, are there any comments or questions about any of that so far? Good. All right, we'll open our JMeter config and do that and start it. So the application should be under load now. It's not running yet, but once it starts up, it should be under load. There we go. We'll start the JMeter job again, and we should start to see that rate increase. There we go. And while that's accelerating, we'll start JConsole again and try to connect to that process. And that's the one I want right there. Unclear why I can't connect to my own process here. One more look at this and then I'll abandon ship on that part. That's not it. That's the one we want. All right, I don't know what's going on with JConsole there, but I'll move on with without that. But what we would be able to do if I could get JConsole to connect to the application is, as I said, we could manage this attribute. So in the JConsole UI, there'll be a thing where you could type in a number and click Set High Volume Threshold. And what that would do is remotely call this method and change the threshold. And the idea there is, even though this would all be running on my machine, if it would actually connect, the JMX management could be done from a whole different machine, right? So you could have your production server running the application and your operations folks running some JMX client like the JConsole. And when the system went into high volume mode, right, you cross some threshold that you're concerned about, the operations folks can respond to that by saying, okay, yeah, we see what's going on here, and we know what's going on. Something happened on /da or whatever, and so we understand why the load is higher than it would normally be. So rather than the way that we're going to react to that is just increase the threshold, right? We acknowledge that we crossed the threshold, and that's okay. So remotely, we could invoke this method and change the threshold from 10 to 20, and now we've got a whole new threshold that will put the thing back into low volume mode until we cross that newer, higher threshold. Does that make sense? So the inability to demonstrate that here hopefully isn't problematic for understanding what the application will be capable of at that point. So back here, take another look at this code. We'll see this is the service we were just looking at. The service simply retrieves a meter from the registry, checks the rate, and if the rate is above a certain point, we do one thing. Otherwise, we could do something else. In this case, we're not doing anything in the else condition. And in addition to that, we've got these methods, again, marked with managed attribute, which would allow us to remotely manage those things. I'm going to take one more stab at trying to get the console to work here. I'm sorry? Mission control. I don't know what mission control is. It's a JMX console. I don't, and so there's no reason to go on a research mission and try another tool that might or might not work real time here. But whatever's going on here doesn't have anything to do with Grails or the plugin. I've got maybe some networking issue. I don't know what's going on there. No, I do this all the time. So despite the current evidence, I really do this all the time, and it works. So maybe I'm just overlooking something simple there. So the plugin is making it very easy to take advantage of the Drop Wizard metrics library, right? So one way to do that is use this trait. You get this mark meter method added to your class, and that's just a really simple one-line way to mark a meter. Another option to do the same thing is you could simply annotate the method with @metered. One reason you might use the annotation, one reason you might use the trait over an annotation is the annotation is a convenient way to meter a method. So you're metering at the method level. It might be the case that you want to do more fine-grained metering than that. So you want to mark a meter at the top of the method, and you're going to do some stuff, and then mark another meter, and do some stuff, and mark another meter. And the annotation, you can't do that with the annotation, right? The annotation is just metering the whole method. If what you want to do is meter the whole method, you could do it this way, but I probably wouldn't, right? It's just one more line of code inside the method that I don't need. If I really did want to just meter the whole method, then rather than use this approach, I would probably prefer this approach. But you could call that a matter of personal preference or style. If you like one over the other, use whichever you think makes the most sense. But where the trait would make sense is if you wanted more fine-grained control and you wanted to decide where in your code you wanted to mark meters. I think it will turn out that if there really are several things that I want to meter within a method, that probably indicates that there's multiple things going on in that method, and maybe I should refactor that and get wherever the second meter would go. That probably suggests there's a boundary there where that should be pulled out into a method of its own, and then I can mark that method with @metered. But so you've got options there, right? You can use the annotation or the trait. The annotation can only be used to meter the whole method. The trait could be used to meter the whole method or any point along the way. Sorry, is there a comment? No? And sort of similarly, if I wanted to time how long a method takes, I can do that by annotating the method with that timed, and I don't have to write any of the code that interacts directly with the metrics library or with the metric registry. And so this plugin is being built on top of the Dropwizard metrics library, but notice there's no Dropwizard library code in our project. We don't see the import statements here, but the metric registry is that's part of the plugin. It's not something that came from Dropwizard. So because we're not writing code that's bound to the Dropwizard library, conceivably there could be other implementations of this in the future. One that uses the Dropwizard library, and another uses some other metering and monitoring and metrics library. And your code could stay exactly the same, right? So you've annotated it with that timed. You've declaratively expressed that you want this thing to be timed, as opposed to writing imperative logic that interacts with a certain library. And if you think about that, that shows up all over the place in Grails, right? So Gorm is the easiest one to think about. When you're writing Gorm code, by default, when you create a Grails application, the Gorm implementation that's in your project is Hibernate, and most people will use Hibernate in Grails applications, but not everyone does, right? You might want to use some other database, right? So there are Gorm implementations for MongoDB, for Neo4j, for Cassandra, for Redis. There are lots of Gorm implementations. And for the most part, there are a couple of exceptions to this, but for the most part, when you're using Gorm, you're writing Gorm code, not Hibernate code or not MongoDB code. And that means that if you were to change from Hibernate to MongoDB, at least large portions, if not all of your Gorm code would be portable to the other database, even though it's a fundamentally different kind of database. The same sort of thing could happen here, right? So @timed doesn't say use the Dropwizard library. That says I want to time this method. Dropwizard just happens to be the implementation that we're building right now, and maybe that'll end up being the only implementation. But not having a compile time dependency specifically on the Dropwizard API is a good thing. Right? So the plugin is being designed with that kind of goal in mind. One more, I'll click that. I don't know why I'm not willing to give up on that thing, but I'll give up on it. So thoughts, comments, questions, ideas, anything at all to say about any of that? Is there a hand? Yep.
How resilient is this plugin on heavy load? Like if you have millions of requests and dozen and dozen of metrics point or timers, is there any chance to have a problem with memory or any other computational problem?
Yeah, the plugin does well with that sort of thing. So as I said, it's built on top of the Dropwizard library, which is robust and certainly well suited for kind of high load situations. It's most useful in those kinds of scenarios, right? If your application's not under much load, then you probably don't. You might not care a whole lot about this sort of thing. So it's important that it wouldn't make sense if the library wasn't well suited for heavy load kind of situations. So the answer is it'll play out quite well in those kinds of scenarios. Anyone else?
So
yeah, go ahead.
I was wondering about more advanced reporting of this, and I mean, obviously logging to the console is only a simple reporting, and I looked at the Drop Wizard metrics website very briefly, and they seem to have other integrations, so logging to CSV files,
Yep.
because I might want to inspect the stuff after my server has died, and logging to other tools maybe for nice visualizations. Could you comment, like from real-world experience, if there are any great tools to use there? What's the best practice?
Yeah, so a lot of folks will want to use a tool like Logstash. So in this simple example, the logging isn't really the interesting part. The logging is just there so we can see the fact that we're crossing a threshold and that the meter is in place and working. But what we did at lines 18 and 20 here, that would be more interesting than just that, probably, right? So we could be, the possibilities are very broad. So the Drop Wizard library in particular has a good bit of stuff in it that directly relates to the question. But even if it didn't, you could do any number of interesting things here. All that's in the plugin so far is what I've demonstrated, and that is there are a couple of annotations, timed and metered, and the metered trait. So all the plugin provides so far is a declarative mechanism for saying that you want the thing metered or that you want a timer in place. And so we'll see how the thing evolves. But that, if it turns out that interacting with stuff like Logstash is something that folks express a lot of interest in, then rather than leave that to the application developer to make all that happen, that would be something that would be good for the plugin to explicitly provide support for. So the plugin, as I said, it's not terribly far along. We've seen most of what the plugin can do. There are a couple of optional attributes on the annotations that I didn't demonstrate. But where it goes will depend on feedback from the community once we start publicizing the thing. So while it's it's not terribly featureful right now. What it does. It does, right? So the timer stuff works and the meter stuff works. So probably what we'll do is round out some rough corners in the implementation, get some documentation in place, and then publish a milestone. And when we do that, more folks will start looking at it and provide feedback, and that'll help drive the thing forward. So if you're interested in this sort of thing, I encourage you to keep an eye out for that. And when that does happen, provide feedback. And the things that are important to application developers are the things that, of course, we would want to add support for in the plugin. Anyone else? We've got about 2 minutes. All right. Thank you all very much. And if there's anything at all I can do to help you out with, let me know.